What is light? Light is made up of the particle called a photon. Not to be confused with a proton, which is something completely different. Photons are spheres of small, tiny matter. And when you get tiny amounts of matter, like one particle, and you move it, what happens is it doesn't move in a straight line. It moves in what they call a wave. This wave motion demonstrated by the black line. Another name for light is electromagnetic radiation. Electromagnetic radiation and light are the same thing. Electromagnetic radiation includes things like heat, includes things like X-rays and gamma rays and ultraviolet, and also includes things like radio and microwaves. When light travels along this wave-like pattern, we can measure how far it is from one point in the wave to the same point in the wave. That's called the wavelength of the light. The wavelength of the light is going to determine what color of light it is, or what type of electromagnetic radiation it is. So the only difference in color we see with our eye is whether this wavelength is shorter or longer. If I were to draw a longer wavelength, it would look something like this. This is one total wavelength. It's longer from here to here than this wave is. If I were to draw a shorter wavelength, it would be something like this. This wavelength is much shorter than the one above. Longer wavelengths tend to be more towards the red side of the spectrum, the color that we call red. If they get very, very long, they become things like radio waves, which we can't see. The shorter wavelengths tend to be the colors we describe as blue, purple, or violet, depending on what's in your textbook or what your teacher likes to call it. These short wavelengths can also include things like X-rays and gamma rays. X-rays are used to penetrate your body in medical purposes to see what's wrong inside, usually, most commonly, to see if there's any broken bones. Once again, all the colors of light you see are the same single photon. They're just moving in different patterns. This means that light acts both as a particle and a wave. They call this concept the wave-particle duality. It means it does both, or it does each of these things. That means that light can bounce off stuff, like a sphere or a ball would bounce off stuff. That's the particle. But light can also bend around corners, which is the wave property.